Hello everyone. In this video we're going to be doing our quick start video guide for profile nesting. Now what I got on the screen here is our quick start guide part for profile nesting. Initially when you run the product you may see some dialogues over here depending on which module you have loaded at the time. For now we'll go ahead and close them. And from the main menu, we'll drop it down and we'll pick Profile Nest. And let's move our object browser down below our machining browser. And we'll size the browser so we can see everything clearly. First, before we get started, let's review what we're going to do in this video. First, we're going to load the Profile Nest module. We will define the machine setup, including the post, nested sheet stock, alignment, and more. And we'll also create our 2.5 axis profiling toolpaths for each of the parts that we want in our nest. We will then set nesting parameters and execute the nest. We will perform a complete cut material simulation of the parts in our nest as well as the nested sheets, and we'll perform some editing. We'll adjust some parameters and re-execute the nest. Okay, let's get started. What we got in profile nesting, what you can do is you may be familiar with our nest module. In that module you can nest geometry into a sheet or an irregular sheet or rectangular sheet. Well, in profile nesting, you can nest actual 2.5 axis profiling toolpaths. So you just need to create the toolpath once, and then you perform the nesting operation, and it'll nest those toolpaths for you. So let's take a look at what we got going in the machining browser for Profile Nest. Here you've got your Profile Nest button. This is a module button that allows you to toggle between different modules. If you click on it, you'll see you can go from the mill module to the turn module to the mill turn module, profile nest module, etc. And then in the profile nest module, you have a nest tab and a simulate tab. The nest tab is where you go through all the operations of creating your nest parameters, creating your profiling operations to be nested, and then obviously the simulate tab is where you perform cut material simulations. If you're familiar already with our milling plugin, a lot of this workflow will be very familiar to you. So let's go ahead and get started and show you how to profile nest the parts that we have on the screen. First of all, actually I want to tell you what part this is. If you go to Open File in the Quick Start folder of the Program Data folder, you'll see the part called Profile Nest Quick Start Guide. Now the Quick Start Guide is the start part, and then there's a Profile Nest Quick Start Guide completed, which shows you what the file looks like after the nesting is complete. Okay, so what we've done initially is we have our parts that we want to create profiling operations for. So these are the parts that we want to nest. And we have down below it a rectangle that represents the nested sheet. And we have the rectangle located in the bottom left corner at the world origin. Now, your nested rectangular sheet, you don't have to create it as a rectangle geometry. That's a little bit easier that way, but you can also create it just by giving dimensions, and I'll show you that in a moment. So let's go ahead and we'll start the process of nesting these profiles. So we're going to go to the nesting tab, and we're going to start from the left and work our way over to the right. For the machine option, in profile nesting, there's only one option, three-axis machine type. So there's really nothing to do there. We'll pick OK, and you can just skip it because it's going to default to 3-axis. Now for our post, you can set your post processor from the posts in the list. We have the Laguna BR-IQ selected by default, and we'll go ahead and pick that. So that you see in the machining job, we have 3-axis machine set, we have our post set, and let's go ahead and create our stock. So we're going to create a box stock, and it's going to be the dimensions of our sheet. So our sheet is 36 by 24, and we're going to give it a thickness of 1/4 of an inch. And you can also turn the stock on and off with the toggles here at the bottom. So now that we got our stock set, let's go ahead and skip back and set our sheet parameters. So we'll go ahead and we have a rectangular geometry already drawn, so we're going to use the select curves option. As I mentioned earlier, if you don't have geometry and you want to specify the sheet, you can give it a name and length, width, thickness, etc., and do that here. But we're going to use the select curves option. We're going to select our curves. Let's turn our stock off so you can see that a little bit better. Let's go ahead and remove all those, cancel those, turn the stock off so that you can see the geometry. So we'll go ahead and select curves. We'll select our rectangle, right click, and you'll see that it adds an item to the sheet selection list. And it's got various columns. You can set the thickness. We're going to set that to the thickness of our sheet, and we're going to give it a total of 3 sheets in our nest. I'm guessing that that's going to take 3 sheets. Obviously, I've gone through before, so I know it takes 3 sheets. But if you don't know how many sheets it's going to take, just put 1 sheet, and I'll show you how to calculate that as you go along, and it'll update the sheet count automatically. So we'll pick OK there. So then we've got our stock. Let's go ahead and make sure the stock is aligned the way we want it. So we'll pick align stock. And let's go to our isometric view, and I'll show you how we're going to align this. So here's the corner of our rectangular sheet geometry. And what we're going to do is we're going to align the stock and make sure that it's aligned. The bottom edge of the stock is aligned with our origin. So we're going to select Z alignment. We're going to pick bottom. So that moves the bottom of the sheet up to the XY plane. And then we're going to move it down to the southwest corner. So we're going to move it in the bottom right left-hand corner is at 0, 0, 0, our world coordinate system, our world origin, and our setup origin happens to be at the same default location, and our sheet is located at that position. So we'll pick OK there and turn our stock back on. So you see here that we have the sheet stock aligned with our sheet geometry at the world origin. So let's go ahead and go back to the top view for now. And also we'll go ahead and assign a material to our stock. It's going to be wood. And pick OK. And if you want to see the wood texture on the stock, there's a toggle for that right here. Typically, I just leave this off for now. So let's go ahead and go to the top view. Now, we did our machine post, define the sheet, our stock, we aligned the stock, we set the stock material. Now for the work 0, as I mentioned, there is a work, if you don't set a work 0 by default, it's located at the world origin. As you can see here, if we turn on and off the WCS, you'll see that we have our machine coordinate system set at the same location, and there's a toggle for that here. So that serves as the origin for the toolpath coordinates if you don't create a work 0. You can, at this point, create a work 0 and put it anywhere you want, and that'll serve as the origin. So we'll just ignore the work 0 for now and go back to the top view. Now, we're ready to create our profiling toolpaths. What we're going to do, we're going to create our first profile and do our first part. So we'll select the 2.5 axis profiling dialog. For the control geometry tab, we'll select curve edge regions, and we're just going to window pick that geometry and right click. So we've got all of our geometry listed in the control geometry tab. This whole part, even though it's 1, 2, 3, 4, 5, 6 different curves, it's going to be this one profiling operation, and it'll keep those keep that operation together in one part. Okay, so let's go ahead and go to our tool tab, and we'll go ahead and create a tool. And what we're going to do is we're going to create a flat end mill, and we're going to make it 2.5 1/4 inch in diameter, and tool diameter 2.5 as well. And we'll leave the rest of the dimensions for the default parameters. We'll set it to high-speed steel, leave the tool number set to 1. And for the feeds and speeds, you can set these however you want. We'll just leave those to the defaults for now for this tutorial. And we're going to save this as a new tool. We'll set this as flatmill-0.25. Save it as a new tool. It's listed in our tools and session on the left, and we'll pick OK. So here's our tool that we're going to use. For the feeds and speeds, we'll just pick load from tool to make sure that it picks up the feeds and speeds that we defined for the tool. And we'll go to the clearance plane tab, and we'll leave this set to automatic, leave the clearance plane set to clearance plane. And for the cut parameters, we'll leave the tolerance set to 1/1000th. We'll leave the stock set to 0, and we'll do a mixed cut direction. And we will use this option here for use inside outside for closed curves. We're going to use outside, and then we're going to use this option for alternate using nesting. So it's going to alternate the tool path because this part has interior cutouts as well as an exterior cutout. So we'll go ahead and do our cut levels tab. We're going to set the geometry at the bottom of the cut, and our total cut depth is going to be 1/4 inch. And we'll leave the rough depth of cut at 1/4 inch as well. So it's going to make one pass. For our entry exit, we're going to do a ramp entry. And the reason we're going to do that, you can do a lines and arcs entry, but just bear in mind that anything outside of this perimeter for entry motions, that's going to be taken into effect when it does your nest. So if you have entry motions sticking out past the part perimeter, that's going to take up more room on your nest. So I'm using a ramp motion that follows the perimeter of the part. So the cutout and the tool path itself will not extend past the perimeter of the part, and that'll keep the nest as tight as possible. So we'll set it at a ramp angle, say 5 degrees, and now the sheet is 1/4 inch, so we're going to go 30/1000ths above the base of the sheet to make sure that we clear and start our ramp motion. For our retract, we're just going to select none. We're not going to have any retract motion. And let's see what else we got here. We got advanced cut parameters. We'll perform some arc fitting. And for the fitting tolerance, we'll set 2/1000ths, which is twice the value of our tolerance, general tolerance. So we'll leave that set. We're not going to use any bridges and tabs. You can, if you're familiar with our milling plugin and profiling, you know that you can set bridges and tabs to keep them in the sheet. Well, for this, let's go ahead and set some. Let's do some rectangular tabs. We'll set the bridge height and the bridge length, 0.1 and 0.2 respectively. And let's go ahead and set the number of bridges to 2. And for the cornering, we're going to do a sharp corner for our profiling. And that's all we need there. For our sorting, we're not going to do any sorting, and we're going to set our nesting parameters. We're going to do a total, how many of these profiles do you want to fit in the nested sheet total? Not just one sheet, but however many you want to machine. So we're going to set this to 25. So we want 25 of this part to be in our nest. So the priority and orientation, we'll leave that alone for now. And let's go ahead and generate that. Okay, so let's take a look at our profiling toolpath. You'll see that we have our exterior profile, our interior profile, and we have bridges and tabs on each of the profile cuts. And you can go ahead and adjust those or eliminate them however you want. But we got one created. Let's go back to the top view. And what we're going to do now is we want one profiling operation for each of our parts. So we're going to right click and we're going to copy it and we're going to paste it and we're going to paste it 3 times. So we got 4 operations. We'll just rename this part 1. We'll call this one part 2. We'll call this one part 3. And also you can select and right click and do a rename to do that way if you want. Part 4. Okay, so we got 4 operations. Right now they're all on the same part, but what we're going to do is we're going to edit them and we're going to remove all the geometry and we're going to select this geometry here for part 2. Everything else is going to be the same, so we'll generate that and we'll do part 3, remove those. Select that one, generate. And then also we'll do part 4, remove those, and we'll select that and generate. Okay, so we got a profiling operation for each one of our parts. And you see our nice 5-degree ramp motion. Okay, so what are we going to do now? We've got our parts profiled the way we want them. The next thing we're going to do is move to the next operation in the nesting tab, is we're going to set our nesting parameters. So this is where you decide how you want the parts laid out in your nest. And we're going to adjust the orientation angle to 45 degrees so we can rotate any of the parts around by 45 degrees. We're going to check this box to allow parts inside of other parts. As you can see, we have a big opening here. We'll see if we can't fit this part inside of that opening so we don't have to waste material there. And for the distance from part to part, we'll keep that at 1/8 of an inch. And we'll keep the distance part to sheet at 1/8 of an inch. And we'll set, leave our overflow minimum utilization, we'll leave that set to 0. And we'll use, we won't do any tagging, and we'll use a stack nesting sheet for the layout. So the sheets are going to be stacked on top of one another. You could also align them along the X direction or along the Y direction. Now here's where I mentioned earlier that if you didn't know how many sheets you was going to need, you could select the estimate number of sheets button and it'll tell you, okay, you need 3 sheets to nest all of these parts, and that happens to be the number of sheets that I set it for in the sheets definition dialog. If you didn't just set this to 1 sheet and then you estimated and it was more, you can just pick the update sheet count button and it'll update the number of sheets. Now, after you get that done is when you want to execute the nest. So when you pick the execute nest button, you'll see that it executes the nest. It adds a nested sheets item to the machining job tree, and it lists each sheet that it nested. So let's pick OK here, and let's look at each sheet. So we have sheet 1. We have a bunch of part number 1s here. We have some part number 3s and some part number 4s. Let's look at sheet 2, and let's look at sheet 3. Okay. So we got all of our parts in there, and as you can see, this one, it rotated at 45 degrees to get it in there. And let's go ahead and do a cut material simulation, or first what we can do is we can get a nesting report, and that's the next option up here on the dialog. So you pick that, and it lists each sheet, and it tells you how many of each part that you have on each sheet. Okay, let's pick OK there. Now what we're going to do now is we're going to do a cut material simulation. First, you can do a cut material simulation of just the parts, or you can do a cut material simulation of just the sheets. Let's do one thing before we do that. Let's say, for example, that this part, we want to make sure that it's always aligned in its orientation as it's drawn, so that it's not rotated. It always stays in this orientation. Let's say, for example, you had a grain direction on your sheet and you don't want this to rotate. You got a sharp corner there, and you always want it in this direction. So what you can do there is we can go to part 3, and we can go to the nesting parameters, and we can say fixed. And by setting fixed, it'll always stay in that orientation. You could also use the grain direction if you wanted to keep it in, like a cross direction of the sheet, or with the sheet, depending on how the sheet is set. But for this example, we'll just say that it's fixed, and we'll generate that. And then you'll see that the nested sheets has been flagged, and we need to generate that. So we're going to go into our nesting parameters. We're going to execute the nest, pick OK, and we see that that part is now fixed in the same orientation that it was drawn. And let's look at the other sheets as well. Same here, same here. Okay, so I was mentioning that you can perform a cut material simulation on either your source profiles or your nested profiles. So let's do our source profiles first. And since we don't have any stock coming up there, let's go ahead and change the dimensions of our stock to go up that high, so it extends up, so we can see a good view of the cut material simulation. So let's go to isometric view, and let's go ahead and do a simulation. Let's slow that down just a bit and pick play. Okay, so you see that, let's go to the top view, that we have the 4 profiling operations. We have our bridges and tabs set for each part. So let's go ahead and do our nested sheet. We'll go ahead and we'll simulate just one sheet. And let's speed this up. So it's going to do each part in the sheet. Okay, so there's our completed simulation. And so let's go ahead and go back in, and we can go back into our Create Edit Tool dialog. You can select it from down here in the Tools tab here, and we'll create another tool, and we'll make that a 125, 125, and we'll make that 125 there as well. And we will save that as a new tool. Okay. Now what you can do, there's a number of different ways you can update the tool paths with the new tool. You can take it and you can just drag it up into there, or you can open up each one and just select a different tool and then regenerate. Okay, so we got the new tool set. Let's go into our nesting parameters, and we'll go ahead and estimate the number of sheets, 3 sheets. Okay, let's execute the nest. And you'll see that it updates the nested sheets. Let's pick OK, and let's look at each sheet again here. Okay, some other edits, anytime that you do any kind of edit, all you have to do is go to the Nesting Parameters tab and execute your nest. And anytime you see a flag on your nested sheets, it means it needs to be regenerated. Now, if you look inside your nested sheets, you'll see that there's a profiling operation for each of the parts in the sheet. If you need, for some reason, to edit one of the instances of this profiling operation, you can go into each one and you can make edits to it. You can edit it and you can regenerate it, and then you can obviously post it out. But the point is that you can get to each one of these operations in the nested sheet and make changes to it if you need to. And then at this point, what we're going to do is, if you're familiar with our milling module, you know that you can get information about your operations. You can get estimated machining time for each of the operations, and you can get it for the entire sheet, and it'll list all of the operations in that sheet, or you can do it for the operation and get information on all of your sheets. Okay, so let's close that. And then also, you're probably familiar with the fact that you can get shop documentation. I won't go into that. It's covered in our milling quick start guide. You can look at that and show you how to print out setup sheets for your machine operator. Now let's do some posting. You can post your profiling operations directly from your operations to nest. You can post them from up here, or obviously if you're wanting to nest them, you want to post the entire sheet. So let's just show it both ways. You can post your entire operations to nest, and there's the post for that. For the Laguna BRIQ, or you can obviously go ahead and post just one of these operations here, or you can come down and post an entire sheet. Or if you want, you can actually go in and just post one operation. So it's up to you.